Welcome back. In today's video, we want to express the following complex numbers in polar form. This is a follow-up for the previous video, which we went over a brief review of complex algebra in which we list several properties to aid us in dealing with complex numbers. Let's get started with today's video. So, first, z, the complex number in polar form, is equal to the magnitude of z times the complex exponential e to the j theta. We then list the following properties which will aid us in dealing with today's complex numbers. The first one is that we can write e to the plus or minus j theta as the angle of plus or minus theta. We use this in our numerical calculations for shorthand notations for the complex exponential. As always, the exponential property can be applied. So if we times two complex exponential together, we then just add the angles. For the magnitude of z, we take the positive square root of x squared plus y squared. Also, -1 is equal to e to the positive plus or minus j theta, which we can write as our shorthand notation as 1. So we could put a 1 here. There's a 1. So 1 with an angle of plus or minus 180 degrees. Also, plus or minus j is equal to e, as you can see, to the plus or minus j pi divided by 2, which is 1 with an angle of plus or minus 90. And also we have power in complex numbers. So z to the 1/2 is equal to plus or minus z, the magnitude of z to a half, times e to the j theta divided by 2. So let's go ahead and start dealing with our numbers. So the first one is z1 is equal to 3 plus j4. Take the magnitude of that, we end up with 5. And as always, should have written that, let's say 7, well, theta is equal to the inverse tangent of y over x, so that I don't have to write that out on screen every time. So now we take the angle, and that's the inverse tangent of 4 divided by 3, and that is equal to 53.13 degrees. Here we have z1. We then do z2. z2 is equal to negative 6 plus j8. Because we have the property -1, we can also factor out a -1. Factor out a -1, get a positive 6 minus j8, -1 in this case, but pay attention to, before we manipulate this complex number, j was positive, so the angle for our -1 will be positive. So we then have a positive 180. And let's keep the magnitude first. So the magnitude for this is the positive square root of 6 squared plus 8 squared, that's equal to 10, times an angle of, and in this case, pay attention to dj in this case. So this is going to be a negative inverse tangent 8 over 6, and that gives us a negative 53.13 degrees, and we times that for our positive 180 degrees, and that's from our -1. But before we manipulate, j was positive, so the angle for our -1 ends up positive, and the j is negative, so the angle for the expression within parenthesis is negative. And if we times both of these together, it's just like timing, like multiplying both complex exponential. We just add the angles. So we add 180 to -53.13. And we will end up with 10, magnitude of 10, and an angle of 126.87 degrees. Z3 is equal to -6 minus J4. We still factor out our negative. We end up with a +6 and a positive J4. We then do the same thing in this case, and our angle. So before, notice our J was negative, so our angle for our -1 is going to be negative. So let's get the magnitude first. So the magnitude is going to be the square root of 6 squared plus 4 squared, and that ends up to be 7.21 times our angle of -1, and that is -180 degrees, times the angle for the expression within the parenthesis, and that is going to be positive. So we times by that to a positive, and that is tangent, the inverse tangent, 4/6. That gives a angle of 33.7 degrees. We add that together, we have a magnitude of 7.21 with an angle of -146.3 degrees. Z3. We then move on to Z4. Z4 is equal to J2, which we can also write as 0 plus J2. This is equal to, take the magnitude of that, we're going to get 2, the positive square root of 0 squared plus 2 squared. Well, my bad. So this should have been 2j, or j2. You can write it any way you want. And that's 0 plus 2j, or j2, any way you want to write it. And if we take the magnitude of this, we have the positive square root of 0 squared plus 2 squared. 2 squared is 4, and the square root of 4 is 2. So we end up with 2. And we can apply the property 5. So we end up with an angle of 90 degrees. We can go ahead. Z5. Z5 is equal to, open parenthesis, 2 plus j, close parenthesis, square. That is equal to, we can do this in step, or we can just do it in all one shot. So let's first do the magnitude, and we can take the square of that. So the positive square root, so the positive square root of 2 squared plus 1 squared is square root of 5. And if we square the square root of 5, we get 5. So we have a magnitude of 5. We then go on and take the angle. So the angle would be, so let's just write that out here. So the angle would be tangent, the inverse tangent of 1 over 2, and that gives us an angle of 26.5. And if we square 26.5, we get, in this case, I think I have to do this one. Didn't do this one, so let's put that in calculator. So 26.5 to the power of 2. my bad. It's not squared. See, in my head, I squared that a while ago, but it's 2 times 26.56. I squared that, and that gave me 702, and that couldn't be right. So thus, it's 26.56 times 2, which is 53.13. And that's in degrees. So that's Z5. We can then go ahead for Z6. Z6 is 3 minus J2, and that's cubed. We can do the same thing again. We take the magnitude and cube that, and if we take the magnitude and cube that, we get 46. Oops, that's 64, so that's 46.9. Then we write the angle. Here we have a negative j, so our angle is going to be negative. And that's going to be a negative inverse tangent 2 over 3. And that'll give us 33.69. And if we cube that, or times that by 3, again, I'm talking about cube. I made that mistake earlier. So we times that by 3. So inverse tangent 2 over 3 gives us 33.69. And then we times that by 3. We get 101.1 degrees. And that is equal to Z6. Go ahead again. The last property we're going to use is power, the power property. So for this case, we have that Z7. And I think I can scroll down a little bit. Z7. Z7 is equal to, in our case, Z7 is equal to, I forgot that, minus 1 plus j to the power half. So that is minus negative 1 plus j to the half. We can do all of that and then keep the half. So we take the magnitude of that, and as always, you would want to get the angle 180. So remember that before anything, so before we even do any manipulation, j was positive. So we can take the 1 out, and we end up with 1 minus j to the 1/2. Well, then again, yep, so minus 1 to the 1/2, so we still have that. We can then go ahead, and our minus 1, as we remember, so let's take the magnitude first. So the magnitude in our case will be, so 1 squared plus 1 squared, we know that's 2, it's square root of 2. So that's basically 1, as always, I think I should, yep, let's just keep, yep, let's write this first. So that's 1.414 times, now we can express our negative 1 as an angle. And before that, we remember that before we factor out negative 1, we had a positive j, so our angle is positive. So we have a positive 180 degrees. And now for our angle within the parentheses, so that's negative. So negative inverse tangent. Negative inverse tangent of 1 gives the angle of 45, so that's a negative 45. A negative 45 degrees, and that's still to the half. We then go ahead and we simplify this by saying, if we use the property here, we take negative 1.414 to the half, to the 1/2. That is, let's include our plus or minus from the property, and that is 1.19. If we add both angles together, the 180 and the -45, we get 135. And if we take the half of that is going to be 67.5. So then we end up with an angle of 67.5 degrees. And basically here we have Z7, which is equal to plus or minus 1.19 with an angle of 67.5. So basically that's it for this video, and it wasn't bad. So I could have probably went a little bit faster, or I think a little bit slower, and write everything out for clarity. But based on the previous video, which you should have watched before you did this one, we already went over the properties, and here we just did that a little bit faster by not expressing the properties or writing out certain things. So that's it for this video. We'll convert from polar form to rectangular form in the next video. So see you in the next one. Bye.